You can see now my slide. So it's about material flow. It's about how to enable flexibility and versatility in battery manufacturing. So it's about really coming from the factory automation, coming from material flow, which is something which is, of course, needed as like the processes, which are, of course, also crucial. Nevertheless, we see that this kind of technologies are sometimes underestimated in respect to their complexity. But let me first start with Bosch Rexroth and what we are doing. So here you can see some glimpse in our portfolio, and our portfolio is quite huge, and it's about moving the parts on the line. So you see on the right side, there's linear motion technology with all kinds of linear motor driven systems and guidings. We can also do web handling with our controls and drive technology. So it's turning the rolls, controlling them, and ensuring that this is working, for example, for roll-to-roll process and electrode manufacturing. But of course, you see also that we have transport and production solutions, means transporting, let's say, the battery pack along the line or the single cells, which you see later. And we have also tightening technology, which is crucial for putting the battery modules and packs together and bolt them. And it's also crucial for recycling, because this is a technology which is important to tear or easily tears things apart if you want to go for recycling. And this is all bundled by Control X Automation, which is our brand. And this is an open ecosystem approach, which is working with all other technologies seamless. So I don't mind if there's other PLCs in place. We can still deal and make it quite easy and versatile with this, let's say, an open technology. So it's along the complete value stream, coming from electrode production until recycling. But coming back to the point, because we don't have too much time. So what is the big challenge to automate the material flow in a gigafactory? And I think it's sometimes underestimated, as I mentioned already. It's really the pure mass which you need to transport. It's 230,000 tons per year, which means per day 700 tons. So if you have a look now to this train, typically in one container, that's the in and out, which you need on cell level. If you think about module and pack, it's even 2 containers, meaning that the part of the train, which you can see here, is produced in one day. And this is a lot of material. Think about small cells and all the different parts which needs to come in. And of course, this needs to ensure, it needs to be ensured that the transporting through the line is seamless and working fluently to ensure that the factory is running. It's not only about the processes itself, it's also about the material. Have a look to the parts of our portfolio, as I already mentioned. So there's PLCs, there's drives, but of course also you see here in the second row different solutions which are for pressing, but also for transporting in different systems. And I will highlight this in the next slides. So it's a huge selection, but the big question is how to standardize and simplify the stuff. So how to select the right one. And you see here some examples what we realized in the past already. And in the middle, you see a stacking machine with a lot of linear motion. You see on the left side a lot of solutions in respect to cell transport, where you see the vario flow. And of course, we are also able to do a terminal pressing, for example, with our press solutions. And these are all working with our Control X system, and this is bundling, let's say, the stuff, and makes life far more easier. But of course, you need to choose and select the right ones, and we are there with our center of competence to support you and to find the right solution. So coming back to the main question, which was how to how to realize it. And I think it's crucial to understand the requirements. And this is just a glimpse now with a lot of different bars. And you see that there is some highlight in the middle. And this is about cell stacking and winding. So this is one of the crucial processes where you need precision, where the takt time is typically lower because the winding or stacking takes more time than the other machines around. So you create there a kind of bottleneck, which you need to ensure that it's not a bottleneck. So you have more machines for stacking and winding typically in comparison to the ones before. So you need to ensure that the material is split in the right way, but also that you combine it afterwards in the right way. Means switches, buffers, and you need to have parallel processing with more machines. Nevertheless, additionally, the black line shows the requirements in machine in the precision, and this is something which is of course also crucial to realize a good energy density and of course also ensure safety on the battery cell level. So in this case, we need really to be precise. It's not only about speed and being able to diverse the material flow, but it's also about precision. And let me shortly highlight this. This is something where a linear motor driven system is working quite fluently. And you see here a link to some animation, but you see also running something on the right side. So you can use the transport system in this case with a linear motor driven system as the first axis of the machinery, which reduces takt time and ensures that it's far easier. And this is just an animation due to the fact that we are not allowed to give you the insight of the real process. So, but I can assure you that we realize such kind of processes already. And of course, it's simplifying your mechanical setup of the machinery, and it's reducing takt time. Of course, it's let's say a very special system which you need there, but if it simplifies your processes, I think it's the right choice. And of course, you can apply them linear motors driven system also in combination with a laser. You can do it for packaging for the modules, as well as using it for pack production. And it's always the same kit, but of course you can do it on different levels. So you see here for pack production, this is also feasible, and we are also highlighting and testing this now currently with a system which is really able to do this with a battery pack with more than 1 ton. So it's not only about animations here, but we are doing this in real life. Another thing which I already addressed is the VarioFlow system, which is a chain conveyor. And you see here some example, and I think this is a perfect fit, for example, to use on cylindrical cells and transport them through either a cell line or to handle the cells to come to a module or a module to a pack line. So this is about high speed, but it's the complete opposite of the linear motor driven system, which we have seen prior to this. So this is same speed approximately, but no precision. And I think you need to combine those systems in a good way. And that's really the key. So you can see here also that this system is working in dry and clean rooms. And for example, also you see on the left side, it's quite easy to realize a vertical curve. Means you can go up and down, and you are enabling to have the material flow on different levels. And I think that's something which is very crucial. And of course, you can use it in dry and clean rooms. Now, coming back to the topic which I already emphasized. So we have seen the linear motor driven system, and we have seen the chain conveyor. But of course, the key for the success is if you combine those two things in the right way. And this is something which we realized in this kind of demonstrator, which you can see here, which we've done together with a partner. And you can see here the independent carriers on the workpiece carriers moving. And there you can now imagine, well, you can do a stacking, you can do a laser process whatever you need. So this is your first access of the machinery, and you can apply processes. You can run those workpiece carriers independently with high precision. And if you're done in the machinery, you run it further down with the chain conveyor. And this is about optimizing the total cost of ownership of the machinery. And I think the good thing is you get this out of one hand, out of Bosch Rexroth in this case, and it's easy to combine those different solutions. And it's just about making life simpler and easier, and using this in a hybrid way to combine it in a clever way in such kind of environments. This is all about TCO optimization, applying the precision where it's needed. And on the other sections, you can do it in a low cost version. So I'm already coming to my summary because Vikram asked me to be sharp and fast. So I think the key message is we need to combine the different technology and to use this really. I did not show it, but the key is also that you can simulate the material flow, and then you're really sure that it will work. And of course, a prod and plug and produce portfolio with cyber physical systems, like I showed you, that definitely helps to optimize it. So our prod portfolio is an enabler for you to standardize and keep it versatile. So thank you very much. So this was a first and short round through our portfolio. If there are any questions, I'm happy if I can to answer them. So any questions?
Andreas, am I audible?
Yes, you are.
Okay. Uh, Now I request the audience to please
I
post
think
any
there's something
questions.
in the chat.
Mm,
No, it was just you, Vikram.
yeah. So we have a question over here. So what are the best practices for ensuring smooth material flow between different stages of cell and pack manufacturing, and how can these be adapted for future gigafactory expansions?
I think key is to standardize it on the different levels. So, for example, if you can do it on a cell level, like I mentioned, where you don't need to have the precision, you can use the vario flow in between of the cells, and this is easily to be adapted, even if you change the machinery. Of course, you need to be aware that maybe also your workpiece carrier should be standardized in some way. It's well for a round cell, it's quite easy, but for especially think about a stack of which you transport, maybe also open an open stacked cell for prismatic cell, either pouch or whatever type. This is very, let's say, crucial part. If you move it, and you're not allowed to shake it, and so therefore you need to have the right, let's say, line set up to accelerate and decelerate it in the right way. And there, I think especially it's key that you have the right workpiece carriers, which you can hopefully use along the line. And if you think about this already in the first place, so that you could put this as a prerequisite, that you want to change it over time in the future, that you use the same workpiece carrier, or let's say the same size, in the different stages. And then you can use, of course, or reuse also the mechanical parts to move it back and forth.
So, do you mean that handling and conveying of cylindrical cells is much easier? or easier than prismatic and pouch? Or,
In some way, yes, I would say. But to be honest, I think both is possible and both will have their markets and their market share. But let's say in some aspects, cylindrical cells are easier to handle. But of course, also there we have some challenges because the number, for example, of cylindrical cells typical per line and per gigawatt, because they are smaller, is the number higher. So it means you have more throughput.
so we have another question. So with Bosch Rexroth's focus on factory automation, how do you integrate sustainability into the material flow for battery cell and pack manufacturing?
Of course, we take care that all our products are developed in a sustainable way. So I'm not sure if everybody's aware, but Bosch Rexroth is part of the huge Bosch company, and Bosch is CO2 neutral as a complete company and was one of the first ones in the world in that size who could claim and say, okay, we are CO2 neutral. Of course, we are still enhancing also our products so that also our not our only our factories and our but also our products support the sustainability of our customers. Something which is then crucial in respect to, let's say, the material flow and how to run it is that you are able, for example, also to stop and only use energy in the material flow if it's needed. For example, consider we are handling a battery pack, a huge one with 1 ton or even more. So we realized a new conveying system, which is the so-called TS7. And this can be done with segmented drive, meaning you're only applying energy if you really move something along the line. And this is some feature which is also from a process perspective highly welcome, because then you can accelerate and decelerate each single pallet in the right way. And also you ensure that, for example, the dispensing of the thermal material flow, if it's not hardened completely, that you are not moving this or shaking it. That's something which, of course, you should avoid. That's something which you can do. But also, of course, this acceleration and deceleration mode helps to ensure that you're only applying energy if it's needed. And we can use this also for smaller systems like the one which you see in my background, that you really stop there, that you don't use, let's say, a stop gate and then it's just running underneath the belt, which you see in a lot of factories. This is something where you also can say, okay, we are stopping, really completely motor and shutting it down. That's possible. And of course, this accounts then to the complete, let's say, setup of the line and reduces the energy consumption. Also, we can feed back energy if you think about this linear motor driven system. If you decelerate, you can get, like for the car with the recalibration, yes, you can do the same also with the linear movement of the machinery. If you apply the right technology, that you feed this kind of energy back into the line and use it in another portion. That's also possible.
Okay. Thank you, Andreas. So I had a question like where does Bosch Rexroth have their expertise in? So whether it's from the start till the end, or is it midway from the cell assembly, or is it even before that from powder handling and even before mixing? Yeah.
Well, we start typically as Bosch Rexroth from the factory automation side. We have a huge footprint, of course, in modular and pack production and assembly. We realized now the first line in recycling, so that's something which you will also find on YouTube, even with some images where you can see the line, or a movie on YouTube where you can see the complete line. And this is one of the first automated battery recycling lines which we realized. Nevertheless, of course, also the example which I showed with the linear motor driven system in the cell side, this is something where we have customers since more than a decade for this system. So I would say you find our products along the complete line. And we are happy that we are covering and we are supporting the complete industry with our material flow solutions. Nevertheless, there are always things which you can, let's say, enhance or improve. And that's our aim, that we make material flow as easy as possible.
According to you, which is the most challenging part in cell manufacturing? In which process do you find that material flow is most challenging to handle?
I would say the most challenging part is if you have a stacked cell and the stack is not yet applied, or let's say within the casing. That's something which where you need to handle it like a raw egg. Yes, you must be very cautious if you have the stack and you're moving this around, let's say from one station, let's say from the stacking position to some press or whatever, or where you do it and assemble it into the cell itself.
Okay. And at the end of the line, while conveying of cells, is it a must that cells should not touch each other for protection, or they can touch with each other?
This depends on the customer. Most of the customers, of course, ask that that the cells are not touching each other
Okay.
to ensure that for quality reasons. But that's normally not a big issue to realize this.
Okay. We don't have any questions from the audience yet. So I think we have come to the webinar, end of the webinar. Thank you very much, Andreas, for the insightful presentation on material flow. And
Thank you.
thank you to our audience who have joined us for the open talk session. And if you have any more questions, you can directly reach out to Andreas, or feel free to ask us at info@batteryline.com. Thanks a lot, and see you all next time.
Thank you.